Hello everybody, and welcome to the Module 13 video for Introduction to Logic. So in this chapter, we are going to learn about the rules of passage. And before I explain what these are and how they work, I'm going to explain why we need rules of passage. Well, one reason is we need to know how to use these rules to set things up for the last thing we'll learn in Chapter 15, but more immediately, consider this sentence I just wrote down. There is some pie which, if anyone is hungry, will be eaten. So, if we were to translate this, I'm not expecting you to be able to translate things like this competently yet, but if we were to translate this into monadic quantificational schemata, so the sort of schemata that we've seen so far, we would get something like, so there is some pi, right? So there exists something that's a pi, and if anyone is hungry, and that's another way of saying if there exists someone who's hungry. So would you? Then it'll be eaten, right? Oops, sorry. WX. Okay. So, this is a perfectly legitimate quantificational schemata. There's nothing wrong or defective about it. The whole thing is, I can't remember the sentence types now, but it's a simple, existentially quantified expression. However, it has nested quantifiers. So what that means is you have this quantifier out here, and then there's another quantifier inside its scope. And we can't apply the method of existential conditionals to this because our method of existential conditionals assumes that the schemata are such that we don't have anything like this. We don't have quantifiers inside of other quantifiers. So there are 8, that sounds right. Yeah, 8 rules of passage for moving quantifiers around so that we can get them into a form where we can do things like apply the method of existential conditionals. There are 2 different forms we'll be converting to, prenex form and pure or purified form. So first I'm going to explain what prenex form looks like and what pure schemata look like, and then I'm just going to give you the rules. And the vast majority of these are not complicated at all. There are 2 that are tricky, and after that, we're almost done learning rules in the class. Okay, so on to prenexity and purification. Okay. So one of the forms that we'll be converting to, and the one that we have the most obvious reason right now to want to convert to, is known as pure or a purified schema. And so the definition of this is a pure quantificational schema is one where the scope of each quantifier contains only predicates bound by that quantifier. And the reason why we would want to convert to this is because a quantificational schema must be pure or purified in order to apply the method of existential conditionals. And so obviously I'm not just going to give you that definition. I'm going to show you some examples. And so everything I'm going to write here is a pure or purified, I think pure is how you say it, schema. So this is just one simple example, right? So let's look at this. So we only have one quantifier. Look at the definition. And every, that's supposed to say predicates with variables. Sorry. My bad. Forgot to write that. because quantifiers don't bind predicates, they bind variables. Anyway, so looking at number one, right? So the scope of each quantifier, or this quantifier, is just what's in the parentheses. The quantifier binds the variable x, and each of these predicates in the scope of the quantifier only contains an x, right? So the only predicates inside of the scope of this quantifier are ones with the same variable that the quantifier binds. Okay? So just another example. And again, these are in the book. So if we have okay, so let's look at this one. And by the way, in case you didn't remember this, so this is just a shorthand way of writing this. We can leave the parentheses in if we want. I'm usually going to not do that, just to save myself some writing. Okay. So here again we check. So there are two quantifiers here. We have this universal quantifier and the existential one. And the universal quantifier binds x, and inside of its scope, we only have predicates with variables that are bound by that quantifier, namely x. The existential quantifier binds y, and again, this is the implied scope if we have something like that. And this, the only variable inside the scope of that quantifier is the one that the quantifier binds. So next one is just this, right? So again, we got two universal quantifiers here. This one binds x's, and inside of its scope, we've only got x's. This one binds z's, and inside of its scope, we only have z's. One more, so we have, and again, this is shorthand for this. I keep wanting to write the a's not upside down. Because you should never, if I ever give you something to translate without a key, don't ever pick A or E for quantificational schemata. I don't know why I did that. That was dumb. Right. So again, here, this existential quantifier binds an x. The only variable in its scope is an x. This universal quantifier binds a w. The only variables in its scope are w's. So it's pure. Then and that's supposed to be a U, I think. QU. And again, here, if you just take a look, two quantifiers. One of them binds X, and within its scope, we only have X's. Another one binds U, and within its scope, we only have U's. One, I guess I didn't remember to put a type of example like this in the book, but if we have, no. Okay, so here, this is also in prenex form, and so there's only one quantifier. It's this universal one. It binds the variable x, and within its scope, because remember, that's what that really means, we only have an x. There is no quantifier that binds this t here. So t is a free variable, not a bound variable. And because of that, if we want to convert an expression that has something like, Trump is orange was what I used that as last week, we won't have any it'll have to be outside the scope of all the quantifiers. Okay, so that's prenex form. Or no, that's pure form. Sorry, shit, it's not prenext form. Next, we're gonna look at prenext form, which is the other sort of form that we'll be using these rules that I'm about to give you to convert to. So the other form is prenext form, and a schema in prenext form has all the quantifiers in a row out front. You'll see what I mean with the examples. So this is an important thing to know going forward. I will remind you in Chapter 15, but in Chapter 15 we learned the main method, which is our kind of universal validity test. It'll work for everything, sort of. For truth functional schemata, the main method just reduces, it is truth value analysis. But anyway, how this works is we just take all the quantifiers and move out to the left in front of all at the very beginning of the schema. Yeah, so I'm just going to show you some examples, and I think you'll see what I mean. So first, this is in prenext form. Again, because all the quantifiers are out in the front, right? So this one's also in prenext form. All the quantifiers are out in the front. So this one's in prenext form. It's also pure, right? And similarly, if you look at the examples from, like this is also in prenext form. And the reason is because it satisfies both of the definitions. So if we only have, a single quantifier and no free variables, then it's usually going to be in, the schema is usually going to be in both prenext and pure form, right? There's no ambiguity there, by the way. Just because some schema can be both doesn't mean that we'll have any difficulty telling with other ones whether they're not either prenext or pure. And so just one more little simple example. There. Again, all the quantifiers are out to the left. And so what we're going to look at next is we have these 8 rules for moving quantifiers around. They're equivalency rules, just like the rules that you learned in Chapter 7, just like, the quantifier equivalencies. So, AX, blah, 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 equals not EX, not blah, 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 right? So stuff like that. So they work in both directions. And here you actually need to get pretty comfortable with using them in both directions because you'll be converting to both prenext and pure form. So I'm just going to go through the rules with some examples. Most of these are fairly simple. There are only 2 that are tricky. So the hard part is understanding what they apply to, not actually applying them. Okay, so let's move on to that. I lied. Before I actually get into the rules, I need to explain one thing that's kind of like a rule. So if you remember, the backwards E distributes over alternation. So, if we have something like... right, so this equivalency holds in both directions, if we have... Oh, oops. Right. And so you might wonder whether or not the universal quantifier distributes over anything. And it does. It distributes over conjunction. So what that means is, and again, this rule works in both directions, and you'll need to apply it at times. So if we have, if for every x is a p and x is a q, that says the same thing as for every x is a p, and for every x is a q. But note that the universal quantifier does not distribute over alternation, and the existential quantifier does not distribute over conjunction. Right? I think if you have been following the method of existential conditionals stuff up to this point, you probably don't need a lot of examples of this because you've been applying the one for existentials. So what goes for existential quantifiers and alternation goes for universal quantifiers and conjunction. I'll show you some examples when I show you some examples of applying the rules. Anyway, let's learn these rules. Okay, so I need to explain how to read the rules. So I'm going to introduce the first one, and this is the first. It's an equivalency rule, and this is what it asserts. And you might be like, you just told me that the existential quantifier doesn't distribute over conjunction, and this looks like it does, except it doesn't, and this isn't. So all of these rules that we have are going to have a lowercase p in them. So it's important to understand what that p stands for, because if you don't understand that, you won't be able to apply any of these rules. So the p there stands for any schema that does not have occurrences, any schema that does not have any occurrences of a variable bound by the quantifier we are moving around. Okay, and what that means is, so let me just give you a really simple example of how this rule might work. So if we have the schema, this, okay, so note that the quantifier that we're moving around binds x's, right? And this right here, this T is an O predicate compound, doesn't have any x's in it, right? So again, this is important. It's a little tricky, so pay attention and make sure you understand this. If you don't, ask me, meet with me in office hours, and I'll try to explain it more. So for these rules, it's true that the existential quantifier doesn't distribute over conjunction because we're not distributing the existential quantifier, right? We're not doing anything to change this p right here. So if we were to apply this rule here, we would get right? Now, one kind of tricky thing is that you can have, P could have quantifiers and variables in it here. It just can't have the same quantifiers and variables, right? And actually, so it's a good practice, and I don't think I'll ever give you anything that violates this, but we can't have two quantifiers with the same variable. So this is ambiguous and isn't a legitimate expression in our language, right? So you'll never run into something like that and be puzzled about it, but you could run into something like or oops, I just did the thing I told you couldn't do. Right, so if we look at this, let me just erase the old one, bring this one up. So if we look at this schema that I just wrote, this one right here, right, the universally quantified expression inside of it, this, satisfies the condition to count as a P here in the rules like this, right? Because we are moving the existential quantifier around, and the existential quantifier binds x's. So right, there's this x over here that is bound by it, but this whole expression here doesn't have any x's in it, right? And because it doesn't have any x's in it, we can apply this rule. It is, for all intents and purposes, the p, the lowercase p here. And so if we were to apply this rule to this, we would get right. And it's important to remember that these work in reverse too. So if we had that's equivalent to this. Right. So this rule doesn't assert that the existential quantifier distributes over conjunction. What it asserts is if we have an existential quantifier and inside the scope there's a conjunction, and one part of the conjunction doesn't have any of the variables that the quantifier binds, then we can turn the whole thing into a conjunction where one side is the stuff without any variables the quantifier binds, and the other side is the existential quantifier plus the variables it binds. I hope that makes sense. I hope. If it doesn't, again, this is important, so please hit me up on office hours. If you're confused about this scope and binding stuff, you probably didn't watch last week's video, so go watch that. Right. Yeah. And so that's how the first rule works. Time for the second rule. So the next rule, rule 2, Quine's really creative with naming these, is make it colorful. Okay. And again here, the P means the same thing. The P refers to any schema that does not have any occurrences of a variable bound by the quantifier we are moving around with our rule. Right? So again, this says something different than saying the universal quantifier distributes over conjunction. Okay? And just one simple example of this. Okay. These two expressions are equivalent. Yeah. I'm not going to try to read these really at all at this point. I just think it's not very helpful to hear somebody say them if you already understand kind of what they mean in our system. And again, these all work in reverse. So if we had, the right side, that would be equivalent to and so yeah, we if we wanted to see, we could also, if we had this, we could apply the rule that we just learned, right? Because the inside of the parentheses down there, it's like we have something like that, and so if we applied rule 1 to that, we would get this. Yeah, just to show you how that works. And if you're like, that doesn't, I'm confused because of the parentheses, remember that this is just shorthand for that. Again, it's because if we wrote the parentheses everywhere we could write them and didn't let it be implied, some of the time we just have like a mountain of parentheses. So all we did there is it's like, we just changed what was going on inside of these parentheses here. And we have to, when we're doing multiple of these, we have to move the new quantifiers out on the right here like this, right? It would be wrong if we had done instead sometimes they'll be equivalent, sometimes they won't. So that's wrong what I just wrote. And again, we have to do it in the order that I did it. Okay. So that's the second rule. And the first 6 of these are real straightforward. So rule 3 is just this. It's the I don't know why the equal sign isn't part of our language. I don't know why I put a dot there. Oops, color scheme. Okay. Cool. And again, this says something different than saying that the existential quantifier distributes over alternation, because we're not distributing it. If we were distributing it, then we have to put it in front of this P here. But we're not. We're leaving the P as is. And again, remember the P just refers to any schema that doesn't have any occurrences of like X, the variable that is bound by the existential quantifier here. And so, yeah. So I'm going to give you an example where it's not kind of quite as simple as the previous ones. Just get used to applying this to real schemata, not just toy examples. So if we have this, X, that's equivalent to right. And again, I think it helps people to recognize that that's an abbreviation. What I just had is an abbreviation for that. So it's like inside of these parentheses that I just wrote here, we have something that looks exactly like the statement of the rule. Perhaps it would be better to write all the parentheses all the time, but Quine doesn't. Which isn't necessarily a statement that's the right thing to do. Quine does a lot of things that probably just make life harder. And so, again, these work in both directions. And so if we had this, right, we'd just end up with the thing we started with. Okay, right. So you've got an existential quantifier with an alternation inside of its scope, and one part of the alternation doesn't have any occurrences of the variable that is bound by the quantifier. You just move the quantifier to the part that does have variables that the quantifier binds and leave the other side alone. Okay? So rule 4 is, again, not super complicated. Same thing for alternation. Oh, I lost track of what rule I was on. Right. Yeah. So again, same rule here that worked for the existential quantifier also works for the universal quantifier. And again, this is not saying the same thing as saying that the universal quantifier distributes over alternation, because it doesn't. What this is saying is that if we have a universal quantifier where the scope is an alternation and one part doesn't have any occurrences of the variable that the quantifier binds, so in our example x, then the whole thing is equivalent to an alternation where one side is that part with no variables bound by our quantifier, and the other side is the universal quantifier governing the stuff that has variables it binds. Okay? And just, continue this trend of simple examples. That's going to be equivalent to this. Right. And it works in both directions. Again, just to hammer this home. So if we have, it's equivalent to what we originally had. Right. Yeah. So that is rule 4. Okay. So rule 5. We have one of these for all of our, or 2 of these for all of our operators except the biconditional. So rule 5. Or wait, I should write the number of the rule, I guess. Wait, was that rule 5? Yeah, no, it wasn't. Okay. And our 5th rule asserts that, well, let me write it, then I'll explain it. Okay, so what this tells us is that if we have an existential quantifier governing a conditional, and in the consequent of the conditional, we have things, our predicates with variables that the quantifier binds, this is equivalent to a conditional where the antecedent is stuff with no occurrences of, say, an x here, and the consequent is just the existential quantifier with its scope restricted to only those variables that it binds, right? So again, just examples. Is equivalent to right, and it also goes the other way. Yeah, I'll do. Oops. Okay. Again, if you understood the previous 4, you probably have that one down. So the 6th rule, as you might expect, same thing for the universal quantifier. And this just asserts if we have something like Oops. Okay. It's pretty much the same thing as the previous rule, but for the universal quantifier. So if you have a universal quantifier governing a conditional where the antecedent doesn't have any occurrences of the variable that is bound by that quantifier, that's equivalent to a conditional where the antecedent is just the stuff with none of the bound variables of that quantifier, and the consequent is that quantifier restricted to its scope. Okay. And again, just examples. So if we have, oh, oops, wrote that wrong. Oh, oops. And once again, this one works in reverse. I'm not going to bother writing it out. Okay, so the last two rules are weird. So let me just give you rule 7, and you'll see why they're weird. So if we have this, right, so this is equivalent to, you might not believe me, but I'll prove it to you at the end of the video, is equivalent to okay, so if we have a conditional governed by an existential quantifier where the antecedent of that conditional has all of the stuff that has all of the occurrences of the variable that's bound by that quantifier, right? If we want to move the existential quantifier in, it transforms into a universal quantifier. I promise you it actually does. And so this is weird. All of the other ones are pretty much exactly what you might expect, but the two rules that deal with moving the quantifier to the antecedent of a conditional will cause the quantifier to change types. So if it's existential, it turns universal, and if it's universal, it turns existential. So here's an example. Oh, oops. Right. Yeah. You just have to memorize this one. It's a little weird, for sure. But that's how it works. Again, I'll explain why. I'll give you literally a proof of why this equivalency is the way it is. If you're curious, I was curious. Oh, and again, this one also works in reverse. I'll actually show you the example because this is a weird one. Okay, right. So yeah, just note that if you're applying either of this rule or the next one, which deals with moving the quantifier, either taking it out of the antecedent of a conditional or moving it into the antecedent in place of a conditional, it's going to change the quantifier type from universal to existential. Okay, and then our last rule, which is almost the last rule, the third to last rule we'll ever need to learn in this class. Rule 8. It's the same thing, but for universal quantifiers. So if we have, something like this, it's equivalent to this. Okay, and just one example. And as all the other ones do, this one works in reverse, so right. And how we use these rules is if we're converting to prenex form, right, we always use the equivalencies from left to right. Or if we're purifying schemata, just stop mixing those up. If we are purifying schemata, we always use the equivalencies in the direction that I've presented them here. So, like this. If we're moving to prenex form, we use them in this direction like that. One important thing to know is that at least I think this is only true of prenex form, but there are different equivalent prenex forms for each schema depending on the order in which you take the quantifiers out. So, and for anything that's reasonably complex, there are a lot of different combinations. And therefore, for the solutions to the exercises or whatever, I might end up posting something that you didn't get that and you're confused as to why you didn't get that. So for the test, we care about whether or not you apply the rules correctly, not whether or not your answer matches the answer that, like, say, I had gotten. Right? And you may have noticed that we don't have any rules for biconditionals. This is actually important, so please pay attention to this. So if we have... something like this, or wait, maybe it has to be biconditional, right? So obviously this is equivalent to, we can apply our old rules for limiting biconditionals here, which would give us right. But there's a problem here, and the problem is that we have two quantifiers that have, if we wanted to move to prenex form, so we wanted to get all the quantifiers, out to the left, we'd have a problem here. And the problem is that the way the rules are written, we can't apply them if there are two quantifiers in the same line that bind the same variables. And I wish I could think of an intuitive, easy way to explain why this works, but I've never been able to think of anything. It's like really obvious to me, but confuses a lot of students. So I'm just going to say it and try to remember it. So if we have something like this, where we have like on the same line, because if they're on different lines, it doesn't really matter. And like if I give you like an argument or whatever, right? But if you have something like this, what you can do and what you have to do to get this to prenex form is the letters of the quantifier don't matter, as long as, and we can change them to whatever we want, as long as we don't, as long as we make sure to replace everything within the scope of the quantifier we're changing. So what I just wrote is logically equivalent to this. right? And so in order to apply our rules, if we ever break up, the main case in which you'll run into this is in a biconditional, because I will give you, otherwise I will just give them to you having done this already, right? So yeah, so if you ever have a situation in which it seems like it's impossible for you to apply any of our rules because you have two quantifiers, and this, I think this will only occur when you're prenexing, when you're moving to prenex form. I could be wrong about that, but I don't think I am. What you'll have to do is you'll have to just change one of the quantifiers. Like if we have two quantifiers with x, because this by itself, without any truth functions or anything, says everything's an f, and this by itself says everything's an f. And obviously those say the same thing, but we don't need to use the same letter to represent them, right? I've been reading them kind of in like super logic-ese, every x is such that it's an f, right? But the variables all just stand for for something in our universe of discourse. So remember, if you run into something like a biconditional you have to break up, and you're moving to prenex form, you're going to have to change the letters of the quantifier. And just remember you do that consistently. So if you have, if for some reason you needed to change the variables here, you have to make sure that you replace all the x's with the same thing. So like, y, that's fine. But if we had replaced one of those with a z, that'd be no, those aren't equivalent, right? Yeah, I hope that makes sense. You won't run into a lot of them where you'll have to do this, but you might. Yeah. Okay, so I'm going to move on to some examples of conversion to prenex and purification and prenexification in a moment. So yeah. Okay, just going to do a few examples of purification and prenexification. I don't know if that's what you call it. Anyway, so consider the schema. And these are from the book. And again, I was going to try to use different examples on here, but it seems like from office hours, most people actually like use the lecture and the book in tandem. So I'm just going to stick with what's in the book. Okay, this is a bit of a nightmare, but we can do it, I promise. So we have this and want to purify it. And purification means we want to make sure every quantifier only governs the stuff that's in its, that a quantifier scope only contains variables that are bound by that quantifier, right? So I'm just going to show you what the applications of these rules and kind of more real life examples looks like. Yeah. So we can start in a few different places here. But actually, no, we have to start with this, right? And we have to start with this because this x right here, we can't do anything to it as of yet. And the reason why we can't do anything to it as of yet is because both sides, so the scope of this quantifier is a conjunction, and both sides of that conjunction have x's in them. So we can't like use our like rule 1 or rule 2 or whatever rule that was. Oops. Okay, so the first thing that we're going to do is we're going to apply rule 8 to this, right? And that will give us, so if we just look at what I underlined in isolation from everything else, so this is a universal quantifier, the scope is a conditional, and the only variables bound by that quantifier are in the antecedent, okay? So what we do is just what's underlined would turn into right? And just put everything else back the way it was, right? Cool. Not bad at all. So next thing we have to do here is we actually, it doesn't look like we can apply any of our rules here, and this is why I had to tell you that the universal quantifier distributes across conjunction. So if we wind up in a situation like this, we have to distribute the universal quantifier, because so this is a universal quantifier. Its scope is a conjunction, and because of that, we can apply our distribution rule to it. So that'll give us and then this is somewhat ugly, but that's okay for right now. Okay, and here we run into those situations that I just mentioned that we have a problem. And the problem is that we, I guess if we're purifying, it doesn't matter. But we could here change so that we don't get confused. I'm just going to do that. We don't actually have to do this here, but it's just not good to have quantifiers on the same line that have the same variables, right? You didn't need to do that here, but you would if you were going in the other direction, right? So, okay, this is looking a little better. So this, in the scope of this universal quantifier, we have a conditional, and the all the variables that are bound by that quantifier are in the consequent place. So we're going to have to use our sixth rule, right? Which will give us this. And we're just applying that. We're only working on that. So oh, oops, didn't mean to write that. Sorry. And that's pure. That's how we purify a schema. Let's look at another example. So let's look at this schema. Okay. And this is actually, as it is in pre-next form, right? Because all the quantifiers are out to the left. So remember, we have to, if we have stack quantifiers in the beginning and we want to move them in, we have to start from the quantifier that's out on the right. Because again, this is the long, the schema that we wrote is shorthand for that. I hope that makes some sense. Okay. And so what we got to do is, well, the first thing we got to do is we got to work on this one. And so here in this conditional, so this is an existential quantifier and its scope is a conditional, and the bound variables, the z, is only in the antecedent. So what we're going to do is we're going to apply rule 7, which will cause the quantifier to change to a universal quantifier, but that'll give us, and then, this, right? Again, pay attention to rules 7 and 8 because it changes the quantifier type. Okay. So what do we do now? So now we have to work on this for all y's, this universal quantifier that binds y. And here we're going to apply rule 6 because the y's here are only in the consequent of the conditional. We have to kind of go a step at a time here. So that's going to look like oh, that should be a, sorry. That's what that should be. I am not fully awake, apparently. Okay. And then okay. And so that's what we've got. And here the smart thing to do would be to kind of drive this inward as much as we can. And so, oh, this is rule 6. So what we want to do is we want to work on this, and we're going to apply our rule. Wait, I wrote this down somewhere. What's the name of this rule? I think this is rule 4. And that gives us yeah. Oh, oops. That should be parentheses. Okay. And so the only thing that we have to do now is worry about this existential quantifier. And so this the scope of this existential quantifier is a conditional, and the x's, the variable that it binds, are only in the consequent. So we are going to have to use, I think it's rule 5. That sounds right at first. I apologize if I'm getting the numbers on this wrong. I'm just going off my notes. I don't actually remember the numbers. Oh, wait. Oops. That's wrong. Sorry. Do it a step at a time. And because if we're moving the quantifier to the consequent of a conditional, it doesn't change types. Right. And then the last thing we have to do is just apply the rule for existential quantifiers and alternation, which I think is rule 3, which gives us and that is purified. Okay. So, yeah, and remember, purification is what we need to do to apply the method of existential conditionals. So next I'm going to give you some examples of prenexifization. Yeah. So consider this schema. This. Okay. I don't know why, but I've suddenly decided that I think that's ugly. Like that. That's prettier. Okay. So when we're converting to prenex form, especially starting from something like this, there are actually a few different things we could do. So I'm just going to start where I feel like starting. And I'm going to apply. This, if we're looking at this existential quantifier here, this whole schema, right, this existential quantifier binds y's, and there aren't any y's in this part. The whole thing's an alternation. So this has the form, for the purposes of our rules, of p, and this is just the p there, or, right? And so if we want to go to this, what we're going to do is we're going to just bring the quantifier out to the front. Simple enough. So this is rule 3. And that's going to be, these are a lot of writing. Right? Cool. So what do we have now? Well, and this is where it can get a little confusing to keep track of the grouping. So what I'm going to do is I'm going to work on this conditional just by itself, right there. Okay. And I'm going to apply rule 7 to our conditional there, which is going to give us, so if we just look at the conditional there, it's going to give us and then I'm just going to fill in everything else, right? Because remember, if we're working with antecedents, the quantifiers change when we move them. Okay, and now what we have here, for the purposes of pre-nexificating this, we are going to apply rule 3, right? Because this or this whole thing is like for the purposes of our rules, it's like, so all of this is like, right, so that's what the structure of that is. And so if we apply rule 3, oops, colors, that'll give us, well, if we're just looking at the underlined portion and we apply rule 3, that'll give us and then yeah, or wait, no, sorry, I screwed that up. Screwed up in an annoying way. That's what that gives us. We're just working on the underlined portion, and then that's all we got to do. Just bring down that the existential quantifier that binds y. Oh, and we need dots there. Okay, so we need to start pulling that existential quantifier that binds z out. So if we use rule 5, right, what we're going to do is and again here we're just looking at this, right? So if we're just looking at that, remember the quantifiers don't change signs when we're pulling them out of the consequent of a conditional. Right, that's rule 5, and then y, and then yeah, I think that's right. Okay. And then we just, the sort of same thing we did to go from here to there. We're just going to do that again to yank the z out one more, the quantifier governing z one more time. And that will occur if we apply rule 3, which will give us and that's prenex, right? And again, that is the same thing as this. I think you're beginning to see why we like dots finally, because without the dots, you'd have like, if we wanted to write everything out in full form, you need like, 20 parentheses or something ridiculous. Okay, so I'm going to work through one more example. So prenex example 2. So okay. So here can't apply any of our rules yet, so we have to break up this biconditional into 2 conditionals, which gives us right. And here we have that problem where we have a bunch of quantifiers that on the same line that have bind the same variable letter. And so we need to make sure, we need to change one of the universal quantifiers and one of the existential quantifiers, right? So what I'm going to do here is I'm just going to make this into W's and this into Z's, right? Because otherwise we won't technically be able to apply our rules. Okay. So, the first thing that we do, I didn't write down I don't have notes for the names of the rules here, but I'm going to work on this first. And because it's in the antecedent, that'll turn into right. Okay. Right. Then I'm going to work on this whole thing, or technically the whole schema. So we do is we pull that W out in front of the whole thing, which is using the, because I'm not writing the rules, I'll explain this. So this, from the perspective of the quantifier that binds W, is the same thing as, like for the purposes of our rules at least. So right. And so we're going to apply the rule for universal quantifiers in conjunctions, and that gives us There, okay. Okay. And then next I'm just going to sort of repeat those steps more or less for that. So first because it's in the consequent, it's not going to change. We move it in front of the whole conditional. So that'll give us just what's underlined there. So okay. Then again, so from the perspective of this quantifier, this whole thing has the form, or sorry, the whole schema has the form, oops. And this is the FC, and then this whole right side is the P. And because of that, we can apply our rule for universal quantifiers and conjunctions. Oh, wait, I forgot to write in the... Right. Yeah, so that'll give us... Okay. And then we basically just do the exact same stuff to the right side that we did to the left side. So I'm just going to kind of blaze through this in steps because it's literally, I mean, it's the exact same thing pretty much. So starting with this, the Y quantifier. Oh, oops, I screwed up. Right. And again, the quantifier changes if we are moving it into or out of the antecedent of a conditional, but in no other instance. And then what we do is... Wait, did I didn't screw that up, did I? No, okay, that makes sense. Okay. Next, we just work on that. So it is the consequent of that conditional. So if we're just looking at what I underlined with the big underline there, that'll give us... okay, and then just writing in everything that we had. Okay. And then all we got to do here is pull the X quantifier out and we're done. And that is in pre-next form. And actually, based on the order that you do this, you could end up with different sets of quantifiers in different orders, right? Yeah, that's just how it goes. So, I did this in a different order that I did in the book, and also I relettered the different quantifiers, and it looks different, but it's equivalent. I mean, I promise that if you connect them with a biconditional and test for validity, it'll come out valid. Okay, and that's basically all there is for this chapter. I'll actually post the justifications of the two weird rules as a supplemental example, because this was longer than I thought it would be. So you only have 4 exercises. They're pretty simple. They're substantially easier than the ones that I just tried to do, I think. So please try the exercises. Again, this is like conjunctive normal form, where it seems really hard, but in practice, whenever you'll have to do it, it's just like with the method of existential conditionals. Conjunctive normal form seems intimidating, but not when you only have to do it to real simple examples. And we don't speak in it's almost impossible to say a sentence in English and have it make any sense or have anyone understand you that's something like this. I mean, you can say it, but it's really hard to communicate the nested structure or whatever. And similarly, we don't usually say sentences that would translate from something like this. We can in mathematics, as you'll see in the next chapter. Sometimes we might actually want to say something in pre-next form. So for every W, for every Z, there exists a Y, there exists an X. That's actually something is occasionally useful. But that's pretty much all there is for this module. Yeah, please try the exercises. They're not too hard. You'll only have to do very simple examples of this.